Have you ever just stopped for a second to think about the invisible world that's humming all around you? I mean, right now, as we speak, signals are just flying through the air. They're connecting your phone to the internet, your laptop to your printer, your headphones to your music. It is this incredibly complex, silent dance of technology. So in this explainer, we're going to pull back that curtain and look at some of these unseen connections. And that brings us to the big question, right? How does all this actually work? How does your phone know how to talk to your TV? And maybe more importantly, how did we get from those clunky, super slow internet pages on the very first mobile phones to where we are today? Okay, let's dive into it. So our journey is going to start way back in the late 90s. The first major hurdle was this. How on earth do you get the internet onto a device that has a teeny tiny screen, barely any processing power, and a painfully slow connection? It was a huge, huge challenge. Well, the answer was something called WAP, or the Wireless Application Protocol. Back in 1998, you had all these tech giants, Nokia, Motorola, Ericsson. They all got together to solve this problem. And their solution was really clever. They decided to create a super lightweight, basically text-only version of the web. It used a special language called WML, which was simple enough for those early phones to actually handle. Now, if you look under the hood, WAP was built in layers, which is kind of like how the internet we use today is structured. Don't worry about memorizing all these acronyms. That's not the point. The key idea here is that each layer had a very specific job to do, everything from handling the data to securing it, all working together just to get a simple web page onto your phone's tiny screen. So yeah, you had layers for the content, layers for managing the connection, but the one I really want to point out is the security layer. This is so important. Even way back in the late 90s with these really basic devices, the creators were already building in ways to handle things like data integrity and privacy. I mean, the foundation for secure mobile communication, it was being laid right from the very beginning. Okay, so WAP solved the problem of getting a single device online. That's great, but what about connecting two devices directly to each other? Without needing a Wi-Fi router sitting in the middle. That's the next piece of this whole puzzle. And this image just illustrates the solution perfectly. On the left, that's the classic setup we all know, right? All our devices connect through a central wireless router. But on the right, you see Wi-Fi Direct. It literally just cuts out that middleman. It creates a direct, peer-to-peer connection between two devices. So much faster and way more efficient. So why should you care? Well, you probably use this all the time without even thinking about it. Every time you print a photo straight from your phone to a wireless printer. Or when you share a massive video file to your friend's laptop in seconds. Or mirror your phone screen to your smart TV. Yep, that's often Wi-Fi Direct doing all the heavy lifting in the background. But what if you need a connection that's even simpler, more immediate? That's where near-field communication, or NFC, comes into play. This is the tech that powers all those tap-to-connect moments, and it only works when devices are extremely close. We're talking centimeters. So this brings up a really crucial point. It's all about using the right tool for the right job, and this chart makes the difference crystal clear. Wi-Fi Direct, it's got a long range, it's perfect for high-speed stuff. NFC, with its tiny 4-centimeter range, is built for quick, secure, and super simple actions, like tapping your phone to pay for coffee or using your transit card. All right, so we've talked about connecting to the web and connecting devices to each other. But what's next? I mean, our airwaves are getting seriously crowded with all these radio signals. So researchers started looking for a completely new way, a whole new medium to transmit data. And believe it or not, they looked up. Just read that question for a second. What if your lamp could give you internet? It sounds a little bit wild, right? But the answer is, it absolutely can. The idea that the very light that's illuminating your room could also be a high-speed data connection, well, it's not science fiction anymore. It's the core of a technology called Li-Fi. So how in the world does this work? This diagram shows it pretty well. You have an LED light bulb, and that's your transmitter. The light gets switched on and off at these incredibly high speeds. Way too fast for our eyes to even notice, and that flicker represents binary data. A 1 is on, a 0 is off. Then a little photodetector on your device just reads this flickering light and converts it back into data. It's so simple, but it's absolutely revolutionary. And the advantages here are really compelling. Li-Fi has the potential for mind-bogglingly high speeds. Plus, it's extremely secure. Think about it. If you can't see the light, you can't get the data. Light doesn't pass through walls. And on top of that, it doesn't interfere with radio signals, which is a massive bonus in places like hospitals or on airplanes. Of course, it's not perfect, at least not yet. The range is pretty short,
maybe about 10 meters. And you absolutely need a direct line of sight. If you put your hand in front of the sensor, boom, the connection drops. The light has to be on, obviously, and that same security feature, the light not passing through walls, that also becomes a limitation if you're trying to cover your whole house.
So we've taken quite a journey here, huh? From WEP to Wi-Fi Direct, all the way to Li-Fi. And each one was created to solve a very, very different kind of connection problem. And that brings us to our main takeaway.
The most crucial point, the one thing I really want you to remember, is this. There is no single best technology here. It's not about Li-Fi replacing Wi-Fi or anything like that. It's about having a whole toolbox of wireless protocols. We use NFC for a quick tap, we use Wi-Fi Direct for big files, and maybe, someday soon, we'll use Li-Fi for super secure, high-speed data in a single room. Each one is a specialized tool for a very specific job. And that's our look at the unseen connections all around us. In just a couple of decades, we've gone from struggling to load a simple text page on a phone to transmitting data through a light bulb. It really makes you wonder, doesn't it? What incredible connection problem are engineers trying to solve right now? What's going to be the next invisible link that changes our world?